Okay, so that's a learning and teaching space, but we're also looking at tools to improve the productivity of the staff. And one of the developments we have is our ICE system, the integrated content environment. And what that enables is, looking at the top of the screen, is different renditions from a single source. So we use XML and XSL, the extensible style languages, to enable the academics who use the ICE system to prepare materials, and then with the press of a button you can either produce a print PDF version, it can go up on the web automatically into Moodle, or we can produce a CD or DVD. Now that increases the flexibility of the academic staff, which ultimately will have an impact on how we enable people to do blended learning or use new technologies. If there were 4 separate systems to produce this, then we wouldn't be able to manage it. And working down from the bottom, it's essentially staff members working with a word processor, either Word or OpenOffice, and using templates that we've designed to enable this easy development and review of their materials, so they can look at it online, see what it looks like, adapt it very easily. So this is going back to the fixed costs of courseware design and development, but I think there are opportunities here to increase productivity. One of the other projects that we're looking at is, can we do the same thing for academic support that I showed you earlier for administrative support? So if students have got questions about a policy on examination dates or deferral, there's usually one correct answer, whereas in an academic support system there are rarely correct answers in a lot of disciplines, multiple perspectives. So what we've got at the moment is a project within the software development lab to try and adapt the same system for academic questions that are typically asked. And they're based on authentic questions, just as Jan Harrington talked about authenticity in the first day. These are authentic questions from students, and they're authentic answers from academic staff, except that we're recording them and placing them in a repository that's searchable. The metadata schema model is a requirement at the moment to put it into the structure of a course and the structure of a discipline. But what we've got now is a trial of a system like this, so that students will be able to self-service. So in a way you think, could students be taught by a database? You know, that we've got authentic questions, we've got lots of interactions. Can that change the cost? Can we limit the amount of face-to-face contact or interactivity by using the technology and making it more accessible? We developed a plug-in to Moodle, and we recorded on a system called Jing, which is outside. It's showing you this plug-in to Moodle, the learning management system.
This is a short demonstration of Academic Assist. As a student, I'm able to ask academic questions using Academic Assist using the new inquiry option. I'm presented with a new inquiry interface where I can ask questions on the left-hand side or select keywords relevant to my query. On the right-hand side, the keywords are highlighted in the questions and the answers. Should I have a question that isn't in the database, I simply type the question, I note there are no answers in the right-hand side, and submit to my lecturer for response. An email is sent to the lecturer.
Okay, this is a real-time capture. You'll see that as soon as the keywords match something in the database, all the previous quality questions come in.
As a lecturer, I'm able to view all questions and post an answer to the question submitted. I select keywords relevant to the student's answer, or I could type in extra keywords that I think are relevant to the topic.
So you can see there that we build a database. So the student has a question. As soon as it matches a keyword in the repository, then the answers come back in. If there's no match, then they submit the question, and the lecturer then types in the answer and just double clicks on any keywords they want. So they tag it as they put it in, and then it becomes part of the repository. So if another question, I mean, that's a very simple example, like what is Ohm's law? It's not typically a question that we would be asked. But I think that it highlights, again, the productivity and the use of technology where students get an immediate answer to their academic question. So what we're trying to do there is create this loop where we don't have lecturers answering the same sorts of questions that come in. And when a student asks a question, they might get answers that are broader, might widen their perspective on the question that they have in a particular way. And we have a quality control and move on this database. So the reusable learning objectives is owned by each of the academic staff members. And if they move on to another university, we'll give them a copy of their own personal repository that they use to interact with students. But the university also keeps any authentic questions and answers that they might have. So again, we're managing this opportunity to give students an immediate response to an academic question 24/7 that will enable them to keep moving to suit their schedule. Some of the other projects that we've got, I'm not going to open all of these, just the top two I'm going to refer to. The other three, the rubric is research universities building research infrastructure collaboratively, and that's a project that our Software Research and Development Lab developed so that we can search across repositories and build common access points across repositories to help students across institutions. And the Arrow project was Australian research repositories online to the world. That's what the acronym is again. And that's another trend that I see, is that we'll increasingly need partnerships with other institutions. No one can reinvent the wheel totally. The resources aren't there. So I think partnerships and networks of institutions will support this. And the bottom example there is the Australian Institutional Repository Support System, this CARES project. And again, that's a project that we manage. So we're supplying support to all of the universities in Australia who are working on repository development, so that ultimately students will have access across repositories. And as open access to research is supported more and more, I think that sort of issue will become really important. So I'll go back to the work that we're doing with the UN's World Met Office. And in that, we're exploring Second Life as a teaching medium. But we're doing it in the way that we make videos called, the term used there is machinima. So what we're trying to do is create scenarios in Second Life, in a virtual world, but we record them as a video. Now, if you think about the costs of doing that, creating an environment in Second Life that can create a virtual video, it's much, much cheaper than trying to make a video that you can use in teaching. And the aim of this is work that the Met Office is doing on climate change. So how do you change the activities of farmers? Because the climate's changing, they need to change their practices. How do you do that in India, for example? How would you do it in China when farmers are, over huge areas? So one of the prototype projects that we've got there is to create machinima that will be used in internet kiosks in the villages in certain parts of India. And I want to just highlight this grew out of a meeting of the UN Commission on Ag Met. But one of the projects that we've got